Nada, how to authenticate a user without a username and password database. Okay, that's the title of my talk. First, before I start, I'd like to say thanks to the organizers. Like Kenny and Angus, you won't see them, but they organize this amazing conference every year. So let's give them a round of applause. Okay? So my name is Simon, or Si for short. I absolutely love Rubyfuza, and I'm really grateful to be here. I was born in Cape Town, and I really love this place, probably my favorite place in the world. But now I live in London with my wife Jen, who is studying her master's. I work for ThoughtBot, which is a bit of a dream come true. If you've written any Ruby or Elixir, you probably know ThoughtBot, and you've probably used some of the open source. We build software products, and the first product that we build is ThoughtBot. So just think about that for a sec. So we're going to run through this app, Nada. TechCrunch says this app literally does nothing, much like my many side projects. Authenticates a user, and I've learned what I wanted about that technology, and then I abandoned it. Nada.com was taken, so I got this app-does-nothing.com. And if you guys are lazy, you can just scan that if you want to play with it, but I'll have that up later. These are some of my heroes. Ricardo especially for today, because he wrote an amazing blog article called Passwordless Authentication with Elixir. And he completely inspired this whole idea for the talk. Joe Armstrong is the co-creator of Erlang. He has like a wealth of wisdom. And Sarah Drasner, this is actually the second time she's appeared in one of my slides because she's so amazing. The first time she wrote this JavaScript program where she was wearing an EEG headset and she moved a box in virtual reality with her mind. Right? Just think about that. She does really cool stuff. Her most recent project, which is really inspiring, is use machine learning to produce a caption for images that are missing alt text, and then add that alt text to the image so that people who can't see the image can read the alt text, which is really cool. A little bit of backstory. I've discovered over the last couple of years that I really hate computers. So you might think it's really weird that I'm up here, and you even saw me kind of fumbling around, like trying to do the projector thing. So you might think, why am I doing this? Because I love what you can do with computers, right? I love the web platform. That's like what draws me to computers. And I just wish they were more natural and easy to use, right? Excuse me. I've been nursing a cold. So I enjoy making software products, and I see writing code as a necessary step, and I see technical challenges as really interesting, but in the same way that things are interesting if you look at them in enough detail, right? I just want to talk about what this talk is not about. It's not about how Elixir works. I'm not going to show you any Elixir code. This is not a getting started guide. I'm not going to tell you whether you should use Elixir. I'm not going to even tell you if you should stop using passwords or databases, right? This is a bit of fun. This is a Friday afternoon, and I'm talking about authentication, so I need to kind of spruce things up a bit. I also know that developers are very analytical thinkers. Is it ready? Okay, cool. So I know that developers are also very analytical thinkers. So you might read the title of my talk and be like, okay, where's he going with this? So I want us to open up our minds. So I want us to, everybody close their eyes. I'd like to invite you to put aside that analytical brain of yours as a developer that's going to think about all the ways that this isn't going to work. And I want you to open your mind and open your heart to what is possible with software. I'd like to invite you to clear your mind. And with that, let's get started. So how does authentication work? I'd like to oversimplify things, so I've made 3 steps. Step 1 is an identity claim. So think of when you're logging into a service, you provide some piece of data that identifies you as a user, right? This is typically an email address, but it could be anything, right? Step 2 is identity verification. So you supply some secret or password that proves that you are who you claim to be, right? So this is typically a password hashed in the database. It could be an OTP or something. Identity storage. This is not strictly required to authenticate a user, but in order to build a useful application, you need to save data that's related to that identity, right? So you need some sort of identity storage. Okay, so we're going to talk through these 3 aspects, and it relates to how do you do this without a username, a password, and a database. So you can see. Sorry. So we're going to talk through each stage, looking at Nada, the app that I built, and we'll talk about what's going on in the background. And because this is Friday afternoon and I'm talking about authentication, I included some multimedia, a little meditation before we start, and now we're going to play a game. So let's play. Do you know how to authenticate a user? Okay, question 1. How would you do an identity claim? Would you A, don't be silly, just use OAuth, okay? Use gate analysis. I googled that, I actually don't know what it is. Use their face. Or D, security is a lie, right? You can't actually authenticate someone. Anybody can get in. So let's vote. A, don't be silly, use OAuth. Anybody? B, gate analysis. Anybody? C, use their face. Okay, some people. D, security is a lie. Okay, the answer was C. Well, I used C. There's no right answer. Security is a lie. So let's play. How do you authenticate a user? Question 2. How would you do an identity verification without a password, right? Obviously a blood test, right? B. OAuth, you'll be assimilated. C, send them an OTP. D, fingerprint or retinal scan. Okay, so A, obviously a blood test. Nobody? Okay, there we go. OAuth, you will be assimilated. B. Okay, C, an OTP. D, fingerprint or retinal scan. Okay, so it's pretty divided on that one. What it is C. So what I used is C, an OTP, right? So we'll get into that. But let's play. Do you know how to authenticate a user? Question 3. How would you do identity storage? Would you A, throw it in a file? That's a database, isn't it? Would you B, Mechanical Turk, an army of humans, write it down on paper? Would you C, machine learning serverless blockchain? That's trademarked for some reason. Keep it in memory and never let the server die. So let's go. Option A. Nobody? Option B. Mechanical Turk. Option C, machine learning. Option D, keep it in memory. Okay, you guys are catching on to this. Okay, the answer is D, we're going to keep it in memory. So how does Nada work? We just got it, right? It uses facial recognition. We're going to convert a face to an email address when the user logs in, so they never have to type the email address, right? So that gets rid of the username part. We're going to send them a one-time PIN to the email address instead of using a password that they have to remember, which is crap. And memory storage, we're going to talk about Erlang. Okay, so this whole talk is a ruse to talk about Erlang, but so I'll let you absorb that a bit. Right, so we're talking about sign up. Sorry, it's in the bottom left here. A lot of you probably can't see that. The user supplies an email address and a selfie to sign up to the system, right? This is how we're going to save their identity so that they can log in without ever typing the email address, right? What happens there is the user supplies their claim, that is the email address and the selfie, right? What the app does is it sends the selfie, which is an image, to a Faces API that I built. The Faces API talks to AWS Recognition. Recognition registers, identifies the face in that image, and then provides NADA a face ID. So it essentially indexes the face so that you can search it later. Really cool. What the app does then is it stores that in memory, the email and the face ID, tuple, and then returns an OTP to the user's email address in order to verify their claim that they own that email address. Right. Run with me? Cool. So S3 is involved somewhere. I don't really know. Okay, how does the user log in? So now we have the store, we have an email and face tuple sitting in memory. The user then submits a claim, which is their selfie, right? They're logging in with their face. It happily sends it on to AWS Recognition. It recognizes the face in the image. It computes the face ID and then returns the ID to us. We look up their email address, and boom, we send them an OTP to log in. There is a step there based on the confidence of how sure we are that face is in the database. We might not immediately send them an email. We might show them a field with their email completed, and they'll be like, "Are you this user?" Just so that a random person doesn't get an email. Right, so let's just quickly recap. What happens when they submit an image is Recognition identifies the face, so you can see the bounding box. It does some clever deep learning machine magic, produces the face ID, and from the face ID we can look up the email address. Okay. We do this without a password using a one-time PIN, so this is like Slack's magic links. And I'm going to make you guys start thinking that you don't need one password either. Sends a link to the email, you click the link, success, right? Storage is a bit more interesting, which we'll talk about later. We're going to use Erlang, and we replace the database with essentially an Erlang process to store the data in memory. So you have the Erlang VM, you have various processes running at the same time, and we're going to store our tuples there. Cool. Cool, let's do a quick demo. Need to figure out how I'm going to do this. Displays. Boom. Okay, I'm going to create an account. Into my email address. Take selfie. That's a bit weird. This is not meant to do that. This is the moment of truth. Actually, might have registered already, so I might need one of you to come up here. Yep. Okay, someone else. Anybody want to volunteer? Okay, so I'm gonna hack it a bit. I'm gonna add a little plus. Demo. Ooh. Ooh. Thank you for your services. Cool. So I should get an email address now. An email. If I don't, then the demo's over. There we go. So Gmail thinks this is spam because it is. I confirm my email by clicking the link which has a little token in it, right? So now I've proved that I own this email address, I'm registered on the system, and Kenny, I need you to come back. We're going to log in. Cool. So this is obviously PSE, so it's not like very slick, but you could make it pretty slick. Right, we found you. You confirm your email address. You could, if you spend like more time doing an alpha version, actually send them email immediately if the confidence is like really high. But I've got this step in here for now. Cool, we sent you a magic link. Click to log in. Boom. Cool. Okay, let's talk about databases. So the reason Erlang works for this demo is because it has multiple fault tolerance mechanisms. I'm not going to talk about them. If you want to learn more about Elixir and Erlang, go do the Get It Started tutorial on Elixir and go read about Erlang. It's really amazing. What we are going to talk about is some history. So if Java is write once, run anywhere, Erlang is write once, run forever. Joe Erlang actually said that. Joe Armstrong actually said that. Elixir is also a hosted language. Kenneth introduced you to the idea of a hosted language. So it hijacks a VM and compiles to it. Also has really great interrupt with Erlang. So you can call 33 years of Erlang open source from Elixir. So here you can see when people say Elixir is like a risky technology, sure, the language is modern. It's a nice modern tool set. But the platform that it's running on is 33 years old. Also, if you use Heroku, use Erlang. If you use WhatsApp, use Erlang. It's more prolific than you think. But why am I telling you about this? What's interesting about Erlang, right? Like, why should you learn it? So Erlang's concurrency model is very similar to that of an operating system, where the concept of a process is a first-class citizen in the language. So let's think about that a bit. In an object-oriented language, the object is a first-class citizen, right? Even a class in Ruby is an object. You can instantiate them, pass them around, model software design around objects, right? In the functional space, this is functions, right? You have function expressions. Your software design changes based on this view of the world. And in Erlang land, we have process-oriented, right? So the idea of an operating system process is a first-class citizen in the language. Really interesting. So in other languages, you build programs, meaning single process executables. In Erlang, you build systems, where you have multiple process pieces talking to each other, right? So you're developing a system. It's actually something Rich Hickey said. And that's what he looks like if you don't know him. Also one of my heroes. And if you think he looks strangely familiar, that's because he looks like James Halliday from Ready Player One. Actually, I just noticed yesterday. It's really cool. So apart from memory storage in Erlang, it has a couple of databases. You can choose Amnesia, ETS, process states, which is what I used, or React. An agent is a wrapper around a process which single purpose is to save state. So it's nothing special, the word agent, it's just what they chose. So choosing a database is a pretty difficult task. Apart from many other technical considerations, like choosing a database that's like ACID compliant and all that stuff, I like to simplify this and just think about how do you intend to query the data. So this is a nice way to think about it. Are there relationships between the data you store, and do you have to maintain their integrity? Are you storing time-related data? Do you need to be able to look at the database in the past? Those are kind of requirements that might pop up in your domain that you might want to pay attention to, and it might influence your choice of database. So typical data storage options, I'm sure you've seen a lot of this. You have relational, object, document, graph, key value, time series, fact tables, and they all have their place. I'm not telling you to use any kind of database. I'm telling you to use the right tool for the job. So what have we learned? Even though the app does nothing, I hope we learned something today. We learned to have fun. I went through this weird moment in my life where I thought life was all about being productive and efficient, but it's actually not. It's about spending time with the people you love. So don't take yourself so seriously. Have some fun. We learned you can do AI. I used to be like the AI guy. I used to identify with that, but I just identify with being Simon now. That sounded kind of weird. If you know how to use an API, you can do AI, right? I built this thing. I didn't write a line of AI. Actually fought with Elixir's request library. And this wasn't true 5 years ago, right? 5 years ago, we didn't have TensorFlow, we didn't have Keras, we didn't have all those cool tools. I wrote when I was back in university, my research in Java. It was like a nightmare. Anyways, Erlang is one of the languages in the book 7 Languages in 7 Weeks. This book, like SICP, which we were discussing earlier in the lunch line, is one of the books that will completely change the way that you look at programming. So instead of just 7 languages, the languages have different programming models. So it teaches you functional, object-oriented, imperative, logic programming, and all of these influence the way that you write whatever language you're writing, right? So if you learn how to write a bit of Clojure and you go back to Ruby, you might think, wow, data as an interface is a really cool idea. How can I use that to model this problem so that I end up with a simpler solution overall? We didn't learn how to choose a database, really, but I think in more general, we learned not to cargo-cult software design. I think it's so important, and this is actually something I look up to OfferZen. The whole idea of having a mission and a team that attacks it is like really appealing. Instead of just writing code, I think we must always remember that we're writing code for a reason, so try fit the problem to the solution, right? We learned to make a responsible decision, hopefully. If there's anything you should take away from this talk, and there's honestly not much, it's just a bit of fun, it would be start asking the question, how could my app be better? Dream a little bit, right? What's possible? There's AI, there's like AR, there's such cool technology, and the web is like absorbing that stuff. There's web Bluetooth now, I didn't know. And then consider, how can I use these things as building blocks for my application? Does it make sense, right? But give yourself a little chance to dream and then make a responsible decision. That's it. I hope you guys have an awesome time this evening. Please join us. Let me just tell you a little bit about ThoughtBot. We're also always hiring, but that goes without saying, right? ThoughtBot developed this amazing book called The Playbook. It encapsulates basically how ThoughtBot works, how we treat our own company as a product, and how that thinking helps us build better software products. We also have a lot of open source. If your company is interested in creating that open source culture, think about what is a problem I can solve for my development team. Create a software product, CLI tool, whatever, script, can be 10 lines, whatever. Share it with your team and make it open source in your company, and slowly you'll start solving more generic problems and opening software to everybody. ThoughtBot produced Upcase. This is like a learning platform, and it was invaluable in my growth as a developer. Recently, the reason I'm mentioning it, Upcase is free now. It used to be $30 a month, and even though the content is a little dated, the principles that you'll learn here will really level you up, so recommended resource. We're talking about Elixir and Erlang, so ThoughtBot has a couple of open source tools in Elixir, like Ex Machina and Bamboo. Those are little like Elixir gem equivalents. We also have a couple of tools, Constable being the most important. It's like company announcements. We use it every day. So yeah, thank you. Come chat to me. Really enjoyed being at the conference. So hope you guys have an awesome time.